All right, so we are almost through some of the coordinate geometry stuff. We did slope, we did midpoint, we did distance on the previous video. This particular video is going to expand on slope. We are talking about parallel and perpendicular lines. This is going to be an incredibly short video. Big thing you need to know, parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. For those of you who are not used to me using actual academic language, means if the slope of line 1 is the slope of line 1 is equal to 7, then the slope of line 2 must equal 7 in a parallel line, and that the slope of line 1 is 7, then the slope of line 2 must equal -1 over 7. Cool. How does that actually turn out to be something useful? How can I test that? They can obviously ask you a series, several different questions, some of them including things like if I give you the equation of a line and ask you to write an equation of a line that is parallel or perpendicular to that line through a specific point, using point slope form to find the answer. The one that I'm actually interested though is in the question that they ask it towards the end of the section. In the distance formula they mentioned that they give you an equation of a line. And that line happens to be 2x plus 1. I want to get to 8, 5, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And they give me the line right here, which is that's not what I wanted. So this right here in blue is the line y equals 2x plus 1, and they give me the ordered pair 8, 1, 2, 3, 4, 5, 8, 5. And they ask us what is the distance between this point and that line. So first you have to understand that when I ask about a distance, I'm not actually asking about any distance. In fact, there's actually a range of distance I can give you. I can give you the distance, there is a shortest distance, and then those distances increase as I go out. You can see this by if I were to connect this particular curve with any line whatsoever, no matter what I wind up doing, I could wind up having a whole slew of different distances. If I were to take this and measure out each one of those, each one of these lines right here is going to have a completely separate distance, but they're all measurements from 2x minus 1. So if that's the case, how on earth do I find the distance between here and this curve? And the answer is that the line that I draw from this curve over here should have, oh my goodness, hold on a second, I want to actually be accurate about this. It goes 2 and up 1, 2. So if I want to go back 8, it should go up 4. Awesome. That was not where I put that point at all. You should have a line that looks like this. Now what happens to be an interesting relationship here is that the red line that I just drew through the point and that blue line happen to be perpendicular to each other. So what that means is that if I have a line, I have a point, all I really need to do is come up with the equation of the red line. Since I know the slope of the blue line is 2, I know that the slope of the red line is -1/2, and I already have an ordered pair 8, 5, I can use the point slope form. Y minus 5 is equal to -1/2 x minus 8 to come up with a new equation. And what I need to do is I need to figure out where on earth do these two equations intersect with each other. So if y is equal to 2x plus 1, I can call this 2x plus 1 minus 5 is equal to -1/2 x plus 4, and I can start solving this problem. 5/2 x. And actually what I would suggest doing, since I was going to work through this whole problem, But in hindsight, what I would suggest doing is I would tell you to solve this and get the y by itself. Notice not get the question in slope-intercept form, but get this question into a y equals form. Remember that you have the access to your calculator. So at this point in time, I just need to figure out when does this curve and this curve intersect. So utilizing my calculator, I went to y equals, and I utilized second trace and found the intersect between these two curves, and found out that these two graphs, as I accidentally left so I don't actually have the answer now, these two graphs happen to intersect at the ordered pair 3.2, 7.4. So if I'm looking for the distance between those, remember we used the distance formula that said that the distance between the x's squared plus the distance between the y squared, take the square root, there's your total distance. I just have to go through and find what is the difference between the 8 minus 3.2 squared minus 5 minus 7.4 squared. And that will get us to our final answer. At that point, it's just plugging in things into your calculator and you are good to go. That is probably the hardest question they will ask you. There may be at some point in time parallel and perpendicular where they get into three-dimensional problems. I don't expect that to occur until the second level test, so I will wait on those until we need that particular question. Right now, the focus is going to be on this with parallel and perpendicular. So hopefully that was a quick run through, something useful, and we will next jump into another application of this topic in organizing quadrilaterals.